Hey Claire, I'm going to give people a chance to get on, and then we'll get started. Just make sure you have some paper and pencil. I'm just going to leave it here for a second and see if there's anybody else that's going to join. I may just be teaching you. Hey, Dulcinea. All right, Claire, Dulcinea, it may just be you two, but I'm going to go ahead and get started, and then I'll save this video to the page in case anyone needs to come back and look at it later. I hope y'all are doing okay. This is really weird. What I'm going to do, y'all don't have to copy anything that you don't want to copy. This is all just extra credit. But this is the stuff that we would be doing if we were still at school. We would be starting a whole section on quadratics. And quadratics are important. So I think it's really important that you do this. I'm going to give you an overall kind of general idea of what quadratics are and then focus on our one specific goal for the day. First of all, a quadratic expression is something like this. This is the standard form for quadratic expressions, and they have a degree of 2. We already learned that the highest exponent that you see on any variable is 2, and that makes it a quadratic expression. Like I said, this stuff right here, especially, you don't have to copy this. You don't really need to. This is just kind of an overall explanation of what quadratics are. And then when I get to specific examples, then it would help you probably to copy those down. A quadratic expression has a degree of 2, and all the graphs that you plot for quadratic expressions form parabolas like this, a U-shaped graph. And there are specific points that you need to know to be able to plot these graphs. So that's kind of the whole general reason that we're going to be doing what we're doing for the next few days, is learn how to find some important points. Some of the most important points on a parabola are the x-intercepts, where the graph crosses the x-axis. And we can do that through solving quadratic equations. And when we solve quadratic equations, there's 3 different ways that we're going to be looking at: solving by factoring, solving by the quadratic formula, and solving by completing the square. And we're going to focus for the next couple of days on solving by factoring. So you're going to have to go back and try to recall stuff from Algebra 1, and I know it's been a long time, so we're just going to act like you've never seen any factoring, and we're just going to start by factoring. And once we learn how to factor, we'll change it into more of the Algebra 2 material and learn how to solve by factoring. But starting today, we're going to learn one of the first steps in factoring. All right, so again, for those of you that are just joining, we're starting a whole big section on quadratics. So this is just to kind of explain that a quadratic expression or an equation, the expression has a degree of 2. And you need to be able to solve these kind of expressions so you can find points on the parabola that make up a quadratic function. And ways to solve to get these important points are what we're going to be doing. And so we're starting today with factoring. Now, let me see. So this is really the start of today's lesson. Let me get it to where y'all can see. I'm sorry, y'all are going to have to bear with me because this is all weird to me. I miss y'all, by the way. All right. So, first of all, I'm going to stop for just a minute. And you tell me, because I want to know kind of how fast to go. So you can tell me if you are going to copy things down or if you're just going to sit back and listen. If you're going to copy things down, I'm going to go slower to give you time. If you're just going to sit back and listen, I don't want to really waste time. So just let me know. Just kind of respond to me, and it takes me a while to get your responses back. But just tell me if you're going to copy or not. Just put yes or no. Yes if you're going to copy stuff. No if you're not. Okay, we have a yes. So I'm going to go slowly. And you can start by just writing down what factoring is. I'm going to kind of show you something right here just to get an idea. This first part doesn't have anything to do with Algebra 2, but I just want to make sure you understand what the word factoring means. So write down factoring and what I've got there beside it. And if I go too fast while you're doing this, it's hard because I don't get your responses. They're delayed. So if you don't get everything copied that you need to, the video will be here for you to go back and look at later. So it says factoring. What factoring is really showing what to multiply to get a specific answer. For example, if I told you to factor 6, that means just show me what you multiply together to get 6. So factoring 6 would be like saying 3 times 2. That's what factoring is. Of course, in Algebra 2, we're going to factor polynomials. So it's not quite that simple, but that's what we're going to be doing. We're going to be showing what polynomials to multiply together to get a specific answer. We're going to start today with this goal right here, factoring out the GCF. And this right here tells you what the GCF is, the greatest common factor. So I'm going to give you a chance to write that down. There's some important stuff here that will help you in your work. So write that down. I'm going to go over what it means. Once you do that, we'll just get to some examples. And Dulcinea, I'm going to give you a chance to get all of that written on that page. And then if you'll just give me a like sign when you're finished, then I can explain it. Okay, I guess that means you've got it copied. I hope that's what it means. All right, greatest common factor. Just listen to what the words say. Greatest means it's the largest. Common, which means they share it. Factor a number that will divide evenly into another number. So the largest factor that two or more polynomials share. When variables are involved, the greatest common factor includes, now this is important, the letters that they share raised to the lowest exponent you see. Now I know definitions are hard to understand until you see them carried out in a problem. So when we do the examples, I'll go back and show you how you can look back at this and see what it's saying. All right, give me a heart if you're ready for example 1. I think I'm going to go ahead. I don't even know if you're still with me. It says you are. I'm going to go ahead and do example 1. Again, if you didn't get everything written down, you'll be able to do that at some point. All right, on example 1, look at the directions. It says find the GCF. All we're doing here, we're not factoring anything. All we're doing is finding the greatest common factor between these two terms. And then that's what this does back up here. It shows you how to find the greatest common factor between two algebra expressions. You first of all look at the two numbers, the two coefficients in front, and you find the largest number that will divide evenly into both 15 and 20. In other words, the largest factor of 15 and 20, the largest factor that they share. And so the largest number that will divide into 15 and 20 is 5. 5 goes into 15, 5 goes into 20. So you write your 5 down. And then you look at the letters, at the variables that they have. And if they share the same variable, like they both have an X, they both have a Y, but they don't both have a Z. That means Z is not in common, so it's not part of the GCF. But you go back to your X, and you write down that letter to the lowest power between the two. And the lowest power is just the first power. So that would be X to the first power. And then you look at the other letter that they share, the Y, and you write the lowest power of the Y that you see, which is the second power. So 5xy to the second is the GCF. That is your answer. If you understand that, do a thumbs up. Hey, Taylor. You can just pick up where we are right now. We're on example 2, finding the GCF. And the video will be here for you to go back and look at to get anything that you missed that you might need to know. I think you'll be able to catch on, though, just from watching the examples. We're only on example 2. Okay, on example 2, again, it says, wait, let me see if y'all can see that. Yeah, y'all can see that. On example 2, it says find the GCF again. No factoring, just find the GCF. So we're going to look, this time we've got 3 terms, 18a squared, 27a, and 36a to the third power. And we're going to find the GCF of all 3 of those. So you look at 18, the coefficients, 18, 27, and 36. And you find the largest... All right, I was just reading your comment, Dulcinea. Okay. Let me get back to this. You find the largest common factor between 18, 27, and 36. And if you aren't good at division, just think of all the factors of 18, all the factors of 27, all the factors of 36, and then you find the largest one that they all 3 have in common. And so that's going to be, anybody, well, I wish I could just answer like right now. I was going to ask if anybody want to tell me what it is. I'll just go ahead and tell you it's 9. 9 is the largest factor between all of these. And so you write 9 down. And then you look to see what letters they have in common. They all 3 share an A. So you're going to be able to use A as your GCF. And remember, you use the lowest power that you see. So the lowest power is just 1. So it's just 9A. 9A is your GCF. All right, so that's finding the GCF, which is the first part to factoring with the GCF. So now we're moving on to factoring, which we'll start with. This is actually our last example, but we've got 4 parts. I know how I like to do A, B, C, D, E, F, G, H, I, J. We're just doing A, B, C, and D this time, today. Because I think y'all are going to understand this, and you're actually going to think it's easy, and then you'll be able to do your IXL and practice it. Hey, Taryn. Algebra 1 will come next. I've actually already done the factoring with Algebra 1, but you're welcome to stay. All right, example 3, we're going to, this time, notice the directions have changed. It doesn't say find the GCF. It says factor out the GCF. So we're going to factor. This time we have like binomials and trinomials, and you always start by factoring out the GCF. You want to pull it out front of a parentheses. So you ask yourself, you look at the 2 terms that are in your problem, 4n to the second and 8n, and you ask yourself, what is the GCF between those 2 terms? So the largest thing that will divide it evenly into 4 and 8 is 4, so you write your 4 down. And then you look to see if they share the same variable, and they do. They both have an n, and you write the lowest power that you see, which is just n to the first. And that's your GCF, but now you've got to finish the factoring. You've got to put the other factor beside it. So now we're going to put parentheses, and inside our parentheses, you're just going to do the distributive property backwards. You ask yourself, what do I have to multiply 4n by to get 4n squared minus 8n? And so, what do you have to multiply 4n by to get 4n squared? It's just another n, because 4n times n is 4n squared. What do you have to multiply 4n by to get 8n? And it's just 2. You have to put the minus down that's up there, because 4n times 2 is 8n. And that's your answer, which looks like a distributive property problem. All of these answers that you're going to do are going to come out looking like a distributive property. Go back and check it, and if you do the distributive property, 4n times n, you get 4n squared, and 4n times negative 2, you get negative 8n. So this is your answer. Isn't that easy? Yes, it is. I'll just answer my own questions. Oh, I missed the interaction. Okay, part B. Look at your 16c to the third plus 10c. Same thing. We're going to factor this by pulling out a GCF. So what is the GCF? So look at 16 and 10. 16 and 10, the largest factor they share, the largest number that will divide into both of those will be 2. So you write your 2 down. And then they both share a c, and so you write the lower power of the c, which is to the first. That is your GCF. Then you put the parenthesis behind it, and now you've got to complete with the distributive property backwards. So you say, what do I multiply 2c by to get 16c to the third? And it's 8, because 2 times 8 is 16. You subtract the exponents, which would make it c to the second, because c times c to the second is c to the third. Plus, what do you multiply 2c by to get 10c? And it's just 5. And then check it. 2c times 8c to the second is 16c to the third. 2c times 5 is 10c. And you have your answer. So I'm going to stop for a second and let y'all say yes if you understand it, no if you don't. Okay, good. We have 2 more, and then I will give you some IXL to do. Okay. I want to give y'all a chance to do it first and see if you get the right answer, but I don't guess we have time for that. 11x to the third plus 22. So you want to tell me what the GCF is? Let's just do that. Just tell me what the GCF is between these two terms. Oh no, is it getting blurry? Oh no. It looks blurry. I may have frozen. I'm going to to see. Let's see. I think that's better, maybe. All right, the GCF here, no one's responding. I don't know if I froze or if y'all are afraid to answer or if nobody's here. So I'm just going to talk to myself, I guess. 11x to the third plus 22. The GCF is 11. And 22 does not have an x, so you can't include x as your GCF because they don't both share an x. Remember, the GCF is the greatest common factor, so they don't have an x in common. So you just write your 11 down and then do the distributive property backwards. 11 times what is 11x to the third, and it's x to the third. And then 11 times what is 22, and it's 2. Then check it. 11 times x to the third is 11x to the third. 11 times 2 is 22. That is your answer. And finally, the last one. I hope to goodness my Wi-Fi is not going to start giving me trouble. I'm going to try. Hang on. I'm going to see if I can just hold it for a minute. Maybe it won't. Alright, I'm going to try to get through this. And I may have to change locations after this, but I think you've seen enough without it being blurry to kind of understand. I wanted to do this last one that has 3 terms. So you look at all 3 terms, and you have 15, 20, and 5. And you need to find the GCF between 15, 20, and 5. And so that's going to be 5. 5 is the largest number that will divide evenly into all 3. And then you look and see what variables that they share. And they share an A. They all 3 have an A. So you're going to write A down to the lowest power that you see it, which is just to the first power. So that goes on the outside. Then your parentheses. And what do you multiply 5a by to get 15a squared b? And it's going to be 3ab. And then minus, what do you multiply 5a by to get 20ab to the second? That's going to be 4. You don't need an a, but you need to put your b to the second down, because 5a times 4b to the second is 20ab to the second. Then what do you multiply 5a by to get 5a to the third? And you don't have to put the 1. You just put your a to the second. And that is it. That is your answer. And so now I'm going to, I see that you said something, Dulcinea, but I can't read it yet. I'm going to go ahead and show what the IXL is. And then I'm going to look at it and answer questions. All right. The IXL assignment that will go along with this is under Algebra 2. And it's SS. Oh, no, that's Smart Score. It's I1. I1 is the lesson number. You need to get a Smart Score of 90, and if you get a Smart Score of 90, that means you have a really good understanding of this. So let me see now what you said. Oh, you were telling me the answer. I'm not really sure what you were typing. 3. But look at this and see if you understand what I did, and then ask me any question that you need to ask me about it. Would you like for me to do one more? Or do you think you just need to practice it? Okay, I'll do another one. Let's see. All right. Let's go with 24 x squared y plus 16 xy squared minus 8z. First of all, figure out what the GCF is. So let's make sure you understand the GCF. We've got, just look at 24, 16, and 8, and what is the GCF between those three numbers? 24, 16, and 8, the largest factor that they share. If you're thinking 8, that is correct. And then look at the letters or the variables that they share. They don't all three share anything, because this one doesn't have an X or a Y. These two don't have a Z. So you can't include any variable as part of the GCF. It's just 8. I didn't mean for that to happen, but I'm glad it did now, so you'll know what to do in case that happens. So then you just divide 8 into all these numbers, and you have to include the variable expressions in the parentheses since they're not out front. So 8 times 3 is 24, so it'll be 3. And then you have to multiply with x squared y. And then plus 8 times what is 16xy squared. And that's just going to be 2xy squared. And then minus 8 times what is 8z. And it's just going to be z, or 1z, but just put z. And I'm holding the camera, so now my writing's gotten bad. Do you understand that? Okay, good. So you work on the IXL that I gave you. There it is again. And if you miss one, be sure and look at the explanation on why you missed it. Try to get a SMART score of 90. And then we'll try to learn a new lesson tomorrow. If you need anything, I'll be checking back. If you have any questions that you want me to show you how to work something out, I'll be checking back, okay? Take care. I'll see you later. Bye.